Welcome to today's First Chesapeake Chat session. I'm Victoria Mulvihill, a First Chesapeake alumni, and I'm here to introduce the First Chesapeake Chat, sponsored by Newport News Shipbuilding. I'd like to take the time to thank this session's sponsor, NBC, for making this chat possible. Just some housekeeping, we'll let the speaker present and then open up for discussion questions later on. But please feel free to put your questions in the comment section as we talk, and we'll try to get to them all. The session today is Cool Jobs, the impact and influence of Woodie Flowers. And I'll now pass it over to Mr. Ken Lesley to introduce himself. Hello.
Well, good afternoon.
How are you doing today?
Well, it's let's just say the world is an interesting place nowadays.
Absolutely.
Yeah, welcome to my new office. This is what used to be the library, and my birds hang out in this room, but now this is my office where I run an engineering program at a high school here in DC.
Cool. Could you tell us a little bit about yourself and just who you are?
All right, very quickly. I'll try to be quickly. So I grew up in Pennsylvania. My dad was a farmer. My mom was a school teacher. And of course, that being the case, there's no way I was going to be either a farmer or a school teacher. But I realized that by actually working hard at school, I could get out of either of those options. And well, basically I ended up at MIT. And that's where Woodie Flowers comes in. So I got to MIT in 1974, and Woodie had just taken over a course that at the time was called 270. It was the engineering design course. Now, I didn't take his class until 1976, fall of 76. Now, let's put things in a little bit of perspective. You know, I was the valedictorian of my high school, but every one of my classmates at MIT was either valedictorian or salutatorian, or, you know, and so, yeah, if you ever understand about statistics and there's that bell curve, well, I made sure that somebody was supporting all the people above me. Let's put it that way. So I had quite a challenge, and changing my major twice was part of that process. So by the fall of 1976, I had already changed my major twice. I joined the mechanical engineering department, which turned out to be the right place to be. And instead of failing courses, now I started passing courses. And one of those first classes that actually had a huge impact on me was, of course, Woodie Flowers' class. He was the guru of design at the time. Like I said, he had just taken over the class 2 years prior. He was completely revamping the way it was run. And it was a lot of fun, and it was an eye-opener. Understanding the process of design is critical. And in fact, it led me to my career in the petroleum industry, where I was designing petroleum tools for the petroleum industry. But anyway, so in 76, I had his class. Just like in first, you're given a project and literally a little Ziploc bag of junk. Hang on, let me turn my phone off. It's sending me alerts from my staff. The year that contest that year was we had to climb a pile of sand. Like I said, literally it was we had popsicle sticks, we had tongue depressors, we had little motors from Polaroid, which coincidentally, the Polaroid's main headquarters was just down the road from MIT in Cambridge. So we had all these cool little things, but they were relatively useless. Let me see if this will turn it off.
We love working from home.
Yeah, there's always a new challenge.
It's okay. You're just super popular. Everybody wants to know what you're up to today.
I'll take that as a good thing. There we go.
Yes.
All right. So, and like in any other endeavor, you know, build, test, you know, concepts. Most people, because we're climbing a pile of sand, we're looking for ways to get good traction on the sand. I said, the heck with that. So I actually built well, basically I was trying to fly over it. And it worked every time until the day of actual test. It actually, got graded. But the good thing was at the end of the semester, Dr. Flowers actually came to me and says, like, your machine didn't work. I says, well, it did every day except that one. He said, yeah, he knew. And actually my machine actually ended up on the ME display case, for the next 2 years. That's a good example of what a way of thinking outside the box, I guess. Now, quite honestly, I didn't know him all that well as an undergrad. I was just trying to survive. But let's move forward now. It's in 2006. Let's go back to 2002. So, as I mentioned, I've been in the petroleum industry. I had designed and built drilling equipment for the petroleum industry, mostly controlled directional drilling. If anybody wants to know what that is, talk to me afterwards. Did that for about 15 years. My wife, who I met at MIT, by the way, she was in the Navy, and something called Desert Storm happened, so I had to stop traveling. As you can imagine, the oil field is in a lot of odd places, many of them not exactly pleasant, so I had to stop traveling. So I got into software development and did that for another 10 years. By 2002, I'm taking a break and looking for other things to do, and my son, who at the time was a freshman in high school, came back and said, Dad, you want to mentor our robotics team? Well, guess what? I've been doing it ever since. So started with Team 928 out of Banneker High School as a mentor. Through doing a favor, I ended up teaching an algebra class at one of the charter schools for a semester, and then actually at that same high school for a year as a long-term sub, and I've been teaching ever since. In 2006, when I got to McKinley, which is where I am right now, and started, if everybody can see, Team 1915, I started teaching math, and in 2008, I started the engineering program, and now I'm the director of the Engineering Academy at McKinley, and of course, the faculty sponsor for Team 1915. Now, getting back to Woodie, shortly after 2002, I actually took Team 928 to Atlanta for the Nationals. Got to chat with Woodie there, and he actually remembered me, which I found shocking because it's only been a few years. He actually remembered my project, but that's one of the awesome things about Woodie. He remembered people. We started a conversation about that time, and then anytime he came to DC or I was back up in Boston, we would chat mostly about education and the importance of how to teach students how to think and how to get things done. One of his quotes that at least to me, was he could train anybody to do calculus. It's just a matter of pattern recognition. What's important, what true education is now what do you do with it and why does it matter? And I've tried to take that philosophy with me as I teach my students now.
I think that's some great advice, because you can, teach students, or you can help present something to students so many ways before you're just throwing information at them. But it's the connection you can make to what they're doing in the real world that I know for me as a student makes the biggest difference.
Well, the things we learn, there's a lot of knowledge out there, and quite honestly, some of it's useless and some of it isn't. But you don't know until you have an opportunity to put it into application. Just like for the engineering and for building the robots, picking a drivetrain, picking a mechanism to manipulate a ball, a frisbee, a cube. Those are all part of that design process, but it's all bringing in different knowledge from a lot of different areas that, when you learned it, you didn't know when you were going to use it or why. And now I have an application, but if you don't know what you don't know, well, you got a problem.
Right. Since you've been with FIRST Robotics for so long, and you've watched it all grow, can you tell us a little bit about even what that creative thinking out of the box of what he saw in your project in your design class, how that's transferred to what you tell your students in the classroom and from a mentor perspective?
Oh, well, goodness. Well, one of the themes I think that goes along with that same idea is the idea that engineering now is so multidisciplinary. So I'm a mechanical engineer. I have enough knowledge to be dangerous when it comes to electrical engineering. I've actually written code, so I understand computer science. That's not in my normal wheelhouse. So it's not my normal knowledge base or my normal skill set. But because the projects are broad enough, I need to either figure it out or I need to find someone else who does. And so, in a company, I might be the mechanical engineer. We might have somebody else who does the drafting to make sure the plans that are going to the shop look good. I've got somebody else who is a specialist in materials to make sure we don't pick the wrong type of steel or things like that. Again, it's like what I was saying before. You have to recognize what you don't know. And sometimes those things you don't know can hurt you. I think we're kind of living in a time like that right now. But be creative, be inventive, because, just because you don't know how to solve the problem today doesn't mean you can't figure it out and there might be a better solution. I've always been a big fan of music, and especially classical music. And so if you look back at the history, when Mozart and Beethoven came along, they broke the rules of the time. And I'm happy they did. We can do the same things. When Woodie Flowers and who's that guy? Dean somebody? Dean Kamen. When they came up with this concept of let's give the kids a pile of junk and see what they build. It's remarkable what we've come up with, how many years later.
Absolutely. Can you also tell us a little bit more about the engineering academy that you are the
my engineering academy.
Yeah, your engineering academy.
Okay, so like I said, I'm at McKinley Tech High School. It's actually a school with a long history. We've been around since the 1890s in one form or another. We moved into the building we're currently in 1926. Originally, it was McKinley Technical High School, and you could do things like drafting. You could learn building trades, how to work with your hands. In 1997, DC was going through a rough time educationally, so they closed McKinley. We're going to tear it down. Well, like I said, a school with that much history and that many alumni in important places, well, it didn't get torn down. It was reimagined as McKinley Technology High School, and in 2004, the 2004 academic year, we reopened. And at that time, we had classes in IT, mass media, and biotechnology. Like I said, in 2008, I started the engineering academy because I saw a need. And besides the fact, and aside from the fact that in my math classes, we were building bridges, airplanes, things like that, because I was teaching geometry. And well, it just made sense. I found that those hands-on projects gave kids they could see why we had to learn geometry. Why did shapes actually matter? So, like I said, I started the engineering academy. Actually, my first couple of classes were in a room in the attic of the building, but shh, don't tell anybody. And so now, moving forward to today, like I said, it's been 12 years since we started the academy. Mass media has moved off to one of the other high schools. We still do biotech and IT. We now use what's called the NAF model, the National Academy Foundation model, where I bring in a lot of what I call work-based learning. Give my students actual opportunities to see what the industry really looks like, construction, engineering, bring in special guests. Everybody has to do an internship. And we have risen to the point where we're now what's considered a distinguished academy, which puts us in somebody said, in the top 5% of all career-based academies in the country.
That's incredible. I think it's really important to go through programs like that where you can really see those applications for science and technology. I know that was something that I was blessed in high school to have. And now in college, I'm seeing how it's, it's shown in the things that I'm doing in each of my classes. We're doing these big projects that I can see why I'm doing what I'm doing.
Right. Well, that does make a huge difference.
Absolutely. Another question that we have for you is, what do you think was the most technologically challenging game in FRC that you've been able to experience?
Oh, my. Oh, good heavens. What was the one where we were running around on the regolith? I'm trying to remember what the name of the game was, but it was quite a few years ago where you could get no traction. And you had to chase your opponents around and dump things in their cart while they kept them from dumping things into your cart. Was that it was a lunar theme. I do recall that.
Was it Lunacy?
Lunacy, yes, that was it. Yes, good name for it. That was quite challenging. I did find that one interesting because it was all about fundamentals. Can you manage the friction? If you could figure out how to manage the friction, which I know a few teams did better than we did, you could do quite well. Otherwise, you were slipping and sliding all over the place.
And what would you say would be your favorite game that you've gotten to experience?
Oh, actually, my favorite game has been Stronghold.
That's my favorite.
I love Stronghold. I thought that was great. We built an awesome robot. The kids drove it pretty well. It did take some beatings, though.
Some of those game elements were brutal.
Yes, that's the good word for it.
Kind of going along with that, what was your least favorite game?
Oh, my. Stacking crates.
Recycle Rush?
Yeah, Recycle Rush. Yeah, that one could have been better.
That was my first game in FRC.
Oh, there you go.
So that one was definitely one that
So the good thing is that the games got better from there, right?
Absolutely. I didn't even know, I thought that was fantastic. So then the next year with Stronghold, I was like, whoa. Right.
Well, and I really like this year's game too. I'm just sad that we only got my team only made it to one competition, but I know there's slight issues with a small little thing running around called a coronavirus.
So speaking of that game, what are you looking forward to doing more of? Are you looking forward to doing more of Infinite Recharge next year?
I think that's a reasonable option. I'm hoping we can do some of the off-season events in the fall, that things have straightened out enough that we can figure out a way to do that safely. I don't know if we would extend that into the actual next competition year. I mean, that would be interesting. But I thought it was actually a very well thought out game. I liked the way it played. And we had a good robot this year.
I mean, the game is being replayed next year. There are going to be no off-season events.
Oh, okay. I'm sorry.
I think confirmed yesterday or something. So
nobody called. No, I'm sorry.
So what are you thinking of adjusting for next season, if you want to share these secrets with us?
Well, obviously, now a lot of this will require me to get a lot of my students back and engaged, but that's a very good thing to look at is we know how the robot performs. So let's evaluate what did well and what we can do better with. That's engineering. So one of the things I keep on my desk at school, which I don't have here, is I have this little block. It's a poppet valve, a little cylinder of it's copper beryllium. I don't know if you're familiar with the material. It's very strong, non-magnetic, all that, because a lot of my tools had to be non-magnetic so we could take subsurface surveys. This particular piece, this little valve, cost my company $50,000 because I made a mistake.
Mm-hmm.
The tool itself, the basic concept worked. We had gone out and we were testing the machine, and we got, I forget, it was 5 to 10 hours into operations, and the thing fails. So, okay, we got to pull it out. I don't know if you've ever been on a drilling rig. I mean, you're pulling it out, 10, 15,000 feet from below surface. You take the tool off, and then, they go back to operation. We take our tool back to the lab. We look at it, find out the poppet valve has a dimple in the surface that's not supposed to be there. Change the geometry. There's that geometry word again. Change the geometry enough that the valve failed. And part of the problem is we just had not anticipated the pressure that we were going to run into. We thought we had a good handle on it, but obviously we were wrong. Redesign that valve, run it again about a little over a week later, it works like a champ. And this is the thing that I want to look at with my team is we know how our robot ran. We've gotten one competition under our belt. We know what we do well and what we don't do well. Let's take a look at that very closely and redesign the things that are not quite good enough and make them better. Look at the things that went well. Can we improve those too? Engineering is a constant iterative process, and we very much want to make sure that that's part of what I teach the students. One of the things I discovered early on in it when I got into education, and this drove me nuts, and I used to drive my professors when I got my master's crazy. It's like, why aren't we improving? We're using a model that is 130 some years old. The history of education in the U.S., Committee of 10 back in 1892, I think it was, set up, basically designed K through 12 education at the time. We really haven't changed that model significantly. If we're not careful, the world will pass us by. And it's because we're not teaching students things that we know work better in ways that we know will work better. So that iterative process is applicable not just to engineering, but to a lot of other endeavors in the world.
I think that's very true. Do you have any other final advice for students in FIRST Robotics, not in FIRST Robotics, to just looking into, where to go with, who they are and the endless possibilities of technology and science out there?
Well, and I talk to my students on this on a regular basis. So obviously I'm a little biased. I think everybody should study engineering, or at the least study some of the sciences. That's where things happen. I mean, if you look around you, everything you touch these days has been touched by an engineer. The principles that we use as engineers are found and discovered by sciences. Those are critical. But always keep in mind that when we solve a problem, we're solving a problem for people. So the context of the problem is important too. So whether it's a social construct or, a cultural construct, you can't, and I hate to say it, I've run into this one because I've literally lived and been around the world a few times. What works here may not always work in Nigeria, may not work in Singapore or Malaysia. People still have needs and they're very similar, but put things into the cultural context and the personal context when you go to solve those problems. So be an engineer, but be cognizant and maybe study a little bit about the politics that are involved. Understand the cultural references that are involved. Those will make you a better engineer, and everybody should be an engineer.
Well, thank you so much for all of your advice. I think it's it's crucial and very important for students just to understand from, you know, somebody who has the experience that you do. Just so thank you so much for being here
Well,
today.
it was a pleasure, and I feel honored that you got a chance to talk to me. That I got a chance to talk to you.
Well, thank you. And thank you again to our sponsor, MVC, just one more time. And have a great rest of your day.